Hello guys, girls, everything in between. Welcome to a 2021 2SH4 final live solve. So I'm going to go through all the questions pretty quick and see how much I can get done. So the first question is question 1, which is a C program where we have to calculate 1 plus 2 plus so on and so forth up to n. Given that n is 1 or greater, it should return the sum of these numbers. So this should be pretty easy, and I am going to bring up a new, oh sorry, that's not the correct window. I'm just going to open up a new file and save this as q1.c as the question tells me to. So first off, we're going to start with the sum while, and I'm going to have it return an integer, and it will accept an integer as well to tell me where to stop, and I will start this at int I is equal to 0. Oh sorry, I should probably start it at 1, and then I'll have the sum start at 0, and finally what I will do below that is I'll stop the while loop. So the while loop will begin at 1, so while, and we have to specify the condition, which is I less than equal to n. As you can see, we have to count n in the sum as well, so I'll have to have it less than equal to, so sum plus equals I, and of course in a while loop you don't have an update condition, so I'll have to manually update it inside the while loop. Finally, we just have to return the value, and that's pretty much the sum while function. We can now work on the sum for implementation using one for loop, and here this is actually a bit easier since first off we won't have to initialize I, and we won't have to include this update statement, but the rest of the code is still important. So this will now become for, and we'll specify the initialization, which is I equals 1, I less than equal to n, and I plus plus, and this should give you the same output as the first question. Not should, I've tested it, it will give you the same output. And finally there's the do while implementation. So sorry, I should rename this function call sum for, and this one is going to be sum do while. I don't have the starter code for this, so I don't know what the headers would look like, but I assume they would look something like this. So again, we have an int I equal to 1, sum equal to 0, so this is similar to the while loop in that we will have to have our own manual update statements. So I will just type in a quick do construct, so do, and as we know, at the end of the do while loop, we'll have to have a while, and then the condition that we're testing for. I'll get to that in a bit, but I know that I have to definitely do sum plus equals I, and I also know that I will have to do I plus plus. Now the trick with this question is that you might go over by 1 because the do while loop only checks its condition at the end of the run, so we have to be careful to not go over by 1. So the condition I'm going to have is while I less than n, because if we can think of n as, let's say, 5 and I is currently 4, this will be true. It will then add 4 to the sum, and then it'll become 5, and it will still add 5 to the sum, but when it checks it, it won't run when I is greater than that. So this is important to do because you have to be careful with what the boundary of the function will be. So that concludes the question 1. And now we move on to question 2. Question 2 asks us to identify substrings of size 3 with distinct characters. This is a pretty easy one, and this is also using CPP. So I'm going to save this as q2.cpp. And yeah, we can just simply solve this using our existing knowledge of strings and such. I think the easier way to solve this would be to have the main method that can the count good substrings that can add a certain that can take a certain string and then substring it a bunch of times, and then I could have a check good substring to take a 3-letter substring and see if it's good or not. So yep, let's get started with that one. So what I'm going to do is I will have this particular function in the start be the function that checks a string. So I'll have it as boolean is good substring, and I will have this be a string that will be a length of 3 usually. if my program works correctly, and this will, as you can guess, return a boolean value. So over here I will then run a simple check. You could do this with a single line, but I'm going to do it with two for loops since that's a bit simpler. So for int I equals 0, I less than str dot length I plus plus, and then we can have the next one for int j equal to, and of course we can start this at just after I because all the previous strings will be checked. J less than str dot length j plus plus. And oh yeah, just realized the bug. I will have to make this str dot length -1, so because j will be looking one letter ahead of it, so that might cause a bug otherwise. But now it's pretty simple. All I need to do is say if str of I is equal to str of j, that is if these two letters match, then I just have to return false, and I don't need to have an else statement because this is technically unreachable. I will just have it after the two for loops end, return true. So now that I have this substring, I can now write down the actual code that's asking me to do this. So I will have this as count good substrings, and it's asking me to return the number of good substrings. So this will be an int count good substrings, and this should take a string s. So string s once again, and that gets us started. So now I just have to iterate through the string and take 3 letters at a time. So this is going to be pretty easy. I will say string sub, or well, I should probably put this in a loop, for I equals 0, I less than str length minus, well, this is going to be -2 since the I'm looking for the last characters of the string, I plus plus, and finally I'll say string sub, so this is going to be the substring. I need a 3-letter string, is equal to, I'm not sure of the string substring method. I think it was pass the first parameter and then the next one. Well, I'm not sure, but it doesn't really matter. I can just do it by hand. So I will have this as a array containing 3 characters, which is going to be s of I, s of I plus 1, s of I plus 2, and then I just need to concatenate all of these. So there we go. And since I'm concatenating them, I won't need the string. So this is a simple way to concatenate these 3 characters, and that should do the substring for me. And if is good substring of sub is false, that is if this is not a good substring, then I will just have to have a excuse me, then I can just break this loop because I know that this is definitely not a good substring, so it will I can just continue this loop and it'll keep going. But if it is a good substring, I should probably put that instead, then we have to do 2 things. We will have to have counter plus plus, and oh, we don't have to print anything. I thought we had to print something. So this will just add to the counter, which I actually haven't defined. Int counter equal to 0. Sorry about that. And yeah, that concludes the method that is for finding the substrings and finding the good substrings, and then we can just return. Oops, sorry. Return counter, and that should give us the final answer. So that concludes question 2. It also asks for a main function, but I think you guys can write a main function good enough. I don't need to explain that. Finally, there's the higher weighted question 3, which is help your instructors perform grade scoring in a few files. So we have a couple of things. So I'm going to start with scorebank.cpp. So I'm going to save this as scorebank.cpp. And this one is going to have a few data types. I'm going to call this class scorebank. And it will have the data types integer, pointer, and float. So I'm going to keep it private for now. As you know, we should always keep data types private as long as we can. So int list and float average. And also they should have a few methods, enter scores, calc average, and print scores. So I'm going to have those public because they will need to be accessed. And this will ask the user how many test scores are needed. So this is going to, I'm going to prompt the user cout. Oh, sorry, I should probably write std. How many scores do you need? And then we can just declare a variable int I equal to 0 for now. We don't actually need to initialize it anyways. And then we will have cin give a value to I as the input number of scores that are needed. And then we just have to allocate enough memory and read in the scores. So this is 1 second. Okay, so we need to allocate the correct amount of memory for this. So that's just going to be a simple new keyword, as I mentioned in the review session. So I already have a pointer. List is equal to new int, and we will now specify the size, which is I. And we then have to read in the scores. For I should probably type in a message real quick, std cout, and I also have to add that to here. Well, I've already used I, but I guess I could just use a different variable. And then we just have to enter the scores in. So this is going to be cin pointing to list of I. And that should conclude the enter scores method. So this is going to be void enter scores. Sorry. And next we have a few more methods to write. Calc average. So void calc average. And this again doesn't take any parameters. Just stores a value. So I just have to loop through the amount of data that I have allocated here. And this is going to just be like going through the list pointer and giving me the values inside it. So this is going to be a for loop starting from I equal to 0 and I less than, oh actually That's an interesting question. What is the size of a list for a pointer? I'm not sure of that. We don't have a data member that tells you how many items are in the list, but I can totally look it up. Give me a moment. Okay, so I just looked it up, and apparently there is technically no easy way to find out the size of a pointer array. So I come up with a little bit of a hack. At the end of the list, I'm going to have this allocate actually a little bit more memory than it needs to. And what I'll do at the end is I'll have the last element in the list. So right now, as we know, J is like at almost at the end. So whatever I'll initialize J outside this over here. And actually, wait, no, I don't even need to do that. Correction. And I'll just set list of I, that is the last value in this list, to be -1. So no one can get a grade of -1, obviously, but I can now check for this. So I will then just set list of I. So in this loop, I'll have it keep running until it encounters a -1. And then I will just use the usual increment operator, and this is going to be a very simple average calculation. So I'll have a int sum, and I will have a well, I'll have the average calculator at the end of it, and over here I will say sum equal to sum plus list of I. And actually here I will have to definitely declare the I outside for obvious reasons. And now that I have the number of items in the list stored in I will then just write this as average equal to, I'll have to cast this as float, so float of sum divided by the list, divided by the number of items in the list, which is I -1, and that should give me the final value, or sorry, it'll just be I, and that should give me the final value of the average. So this will then store it in the data member average. Finally, we just have to print out the test scores. And this will be it won't take any parameters, so this will then just print the list of test scores to the screen as well as the average. So first off, I'll write it as print the test scores, so std of cout test scores, new line. Oh yeah, I should probably add some new lines in the previous part of the code as well, so good thing I did that now. And yeah, that's all the inputs. Over here it's going to be another for loop. And here I can actually, I don't think I will need to reuse the value of the number of elements in here, so I can make that a temporary variable to reduce the amount of stress in the stack. And I will just print out the test scores as they are, so cout list of I. And finally, I have to print out the average, so std cout. I again forgot to add it to namespace, so I'll have to definitely add it here. It would be much easier to add a namespace, but I'm just too lazy to scroll up and actually do it. And then the beauty of C++ is that we can just do this. Right, and that should be it. So that concludes the score bank. We've implemented everything. Oh, we have to add a constructor and destructor. Okay, so in the constructor, we have to free the memory allocated in the class. I'm guessing destructor will do the exact same thing. I don't know the given constructor, but it's pretty obvious what it is going to be. It's going to be score bank, taking no parameters, and this will just delete list. Sorry. There we go. And I will just do the same for the destructor. So the destructor, as we know, is specified with the tilde. So tilde score bank. And this will take no parameters, and then we will just delete this as well. And there we go. That completes the that completes the CPP code. The scorebank.h code will just be a continuation of this. I won't be doing that. It's just going to be write down the headers, and that's kind of boring. Right, and then there's part B, which is the first curving method. So we have to derive from scorebank a class curve1. So I will write down a, and since we're deriving, I should probably make these protected since I'll be needing those values. And this will be a class curve1. So I'll save this file as curve1.cpp, and I will need to have a few methods in this. So class curve1, and the derive symbol is the colon, and I'm going to inherit everything from the above method as public. And then it's just going to be a simple case of implementing all of these. So we have to free the memory allocated in the class, and this doesn't have any additional features, so I'm just going to call the parent constructor instead. So there we go. And then the destructor will be the same. And well, if I call a destructor on this, it'll automatically call the destructor on the parent method, so no need to worry about that. Finally, we actually have to implement the methods, which is the method curve. And this will take no parameters, but it should set the average score to 75 if it's less than 75. So I should probably first find out the difference between the current average and 75. So diff int diff is equal to well, I'm hoping that it's going to be the average is less than 75, so 75 minus average. And I will now check if this is if the average is actually less than 75. So average less than 75, we must set it to 75. Actually, I should move this declaration inside the if statement to try and save some memory, just for optimization's sake. It really doesn't matter, but I just want to be neat with it. So that is the difference, and we also need to add this particular value to every single test score. So I will go to the test scores, which is the list. So to access the parent method of a list, we will have to use the score bank. So I should probably use that here as well. Oh, sorry, I keep naming these the wrong thing. It's score bank. And then finally, I will have to replace the average and add the value. So, and I can set the value because this is public in this scope. If I was using this in a object of scorebank, this would not allow me to do it. we go. Oh, I just realized my mistake again. I keep forgetting that in this programming language, it's not about the end case, it's about the uh, validity case. Sorry, I've been programming in another language where the for loop actually doesn't have that. It's where you specify the parameter where it's supposed to end, not what it's supposed to check for. Anyways, this will now work. I don't need this semicolon. Wouldn't change much, but I don't need it. And in here I need to add the particular value, so and again I can edit this because it's in this scope it's correct to edit. And I forgot to specify the return type, which is void. There is no return type for this. I hope I specify the return type for these. Yep. And then finally we have you have to overload the print scores method to print out all of these. So the print scores method was just void print scores, so I can overload this. And this is definitely overloading that method, but now we have to print out a few things, the original scores, the curve scores, and the original new average. So now we will have to be clever about this. I will set the then I should probably set the internal averages to be something different. So I will set this is going to apply to the average values in curve 1, not the values in scorebank, so this will make it a bit easier. And over here I will just have to print out the correct values. So the original scores are stored in scorebank, so now I will have to print out the original scores. So cout, as usual. I should have just added it to namespace. And I will just copy this for loop because I'm very lazy. And this is going to be the score bank. So as you know that a value can have two values, it can be the parent class will have a certain value and the child class will have a copy of those values. And of course these are not mutable, so these won't be in the above score bank since I already called the parent constructor to give it the values that it needs. So no problem with that. Right, and I don't need to actually print out the diff, I just need to print out the value over here. So cout, and now we have to print out the new scores. So again, just copy paste this down here. Oops, my indenting is a bit off. There we go. It's even more off. I'll let it slide. And this time we're looking for the actual list. The length isn't really different, so this shouldn't change anything, but this will change something definitely. And finally I need to print out the original new average, so std, and I can probably do this in one line. I forgot to put new lines as usual. /n and /n. I can also put a new line after this. If you're wondering why I'm not just writing /n here, I don't know why, I'm just lazy, I guess. This will definitely work, so it doesn't matter. So this concludes, oh sorry, this is the end of the scores now part, so I can then write over here the average. Perfect, and this should work out. So now we have the memory all freed up, and this is all working as intended. And yeah, that's pretty much it. Yeah, I should also actually add to this a line that calls the parent method, because otherwise I will have no way to add values into this. So I'll just say score bank dot enter scores. There we go. Perfect. So this should all be working now, and we have the given constructor and destructor, and of course I can add to this a bit of code to free up the memory that I allocated here, specifically to curve1, which is going to be the version of list that's stored here. So delete list. So now both versions of list will be deleted, this one, and of course it automatically calls the scorebank.cpp destructor, which deletes that list. And that concludes that part. So now we have another class, curve2. So I will make a new file, and I will save this as curve2. Oh, sorry. I should probably rename this. There we go. Now it should work. So we start off with the method curve, which sets the high score to 100, scales the rest of the score accordingly. So this is important. We will have to work with a sort of scaling algorithm in this particular class. So again, this is a lot of boilerplate code. It's not very engaging. And I'm basically just going to copy paste the entire code from this particular section, because a lot of it is going to be an overlap. So not only are we overloading the print scores method, we're also overloading the curve method. They haven't actually mentioned that, but that is also the case here. So in this case, we have to just rework the curve method. So the curve method asks me to set the high score to 100 and scale the rest of the scores accordingly. So this is so this will require me to sort the scores, and thankfully there is a nice way to sort a list in C++. So I will just be using that. So the sort function, I think, is standard in the STL. So I'm just going to work with that. Oh, I have to actually look up the function for where it should start. Okay, perfect. So it's basically just a simple pass the first parameter, pass the last parameter. If I didn't want to do that, I could implement my own bubble sort, but I don't think that really matters. Or actually, there might be a simpler way to do this. No, there's definitely a simpler way to do this. All I have to do is find the highest score instead of actually sorting the array. So I'll do that real quick. And since I'm going to be working on a mutable copy of the list, I'm going to be working on the copy of the list that's currently in curve2, not the one that's in scorebank. They are the same for now, but they won't be the same for both of them. So actually, oh yeah, I just realized I haven't actually given the curve any way to put values into itself. So I'm going to quickly change that. that's the correct way to do it. Oh, sorry. It's not going to be that. It's going to be score bank list. And this will then point to the exact same array in memory, so it won't take up any more memory. Just point at the same one. And then avg equal to perfect. And over here I can then actually work on the algorithm as I was going through it. So list of I is not equal to -1 and I plus plus. And then finally we just have to check for the highest score. So I'll set a variable outside this, highest equal to -1, because no score can be lower than -1. And or actually I'll set it to list of 0, and I will say if perfect. So this will just give me the highest value. It's a very simple algorithm. And now that I have the highest value, I need to figure out the scaling factor between these. So I'll call this float scale factor, and I'm going to set the highest score to 100. So I have a bunch of scores. I just have to set the highest one to 100, and the highest one is stored in highest. So the scale factor is going to be 100 divided by highest. And now that I have the scale factor, I just need to again iterate through the entire array, through the entire local list, and multiply each element by the scale factor. Now this will usually round down. I'm guessing that's the intended behavior because I'm working on an integer multiplied with the float. So it'll always round down, and I'm guessing that's what they expect. But if they ask you to round it up, you'll have to typecast this to float and then typecast the result back to int, and then you will get the answer. Right, so that completes everything, and yep, that's the entire file done. So this will reset the value of list. It never told me to oh, but it did tell me to print the new average. Just didn't me to calculate it, so I might as well add a line here that can calculate the new average. So once again, since I'm already going through the list, I might as well add a sum. And over here, I'll just move this I out of the loop once again, the same trick I was using earlier, to kind of find out how many values are in this. So this will then add the updated values of the list to the sum, and then I can say the local copy of the average, avg, is equal to sum plus equals list, sum divided by I, where I is the number of elements in the list, and this will then give me the correct answer. Again, I should probably typecast this as float, since the initial value is a integer, and this should give me the final average, which then gets printed out over here. So okay, and there's also the main function. Again, you guys can work this out. It's just going to be basically just follow this and copy paste it. Okay, and that concludes it. I hope you guys enjoyed it, and good luck on the exam that's coming up. If you have any more questions, feel free to drop me a line.